Alright, let's go ahead and get started then. Page 239 is this chart. We're going to have to turn it sideways here. There we go. So we're still dealing with these rational functions. And now, after yesterday's lesson, there's multiple things we can determine. The restricted numbers that we talked about, we can find the domain, and we're going to be able to find y-intercept today, and we'll explain how to do that also. So over the next few lessons, we will learn how to develop the graphs of rational functions and to understand the connections between the equations and the function, the equations of the function and the graph of the function. So we're going to determine how to find the restricted values, the domain, x-intercepts and y-intercepts of the graph of the function. Identify the following characteristics using the graphs from page, and that should be page 238. I don't know if it's changed on your page or not. 238. So that's the page yesterday from the notes where we had written how one was different than the other. We're going to be referring to these pictures. So you want to be able to have this out. If you want to take it out of your notes, have it beside it, or if you can just flip and see it, we're going to be using this page too. Alright, so the first one is f of x. So f of x, referring to the f of x graph on that previous page 238 that I was referring to. But the first box says we need to rewrite the function in completely factored form and identify the restricted values. So we want to write this in factored form. So we need to factor the top and we need to factor the bottom. So go ahead, try to factor the top and factor the bottom. Is anybody successful with the top or the bottom yet? Go ahead, Tori.
The top is x plus 6, x minus 6.
Yeah, x plus 6, x minus 6. Very good. And the bottom, Rebecca?
And goes 2x and then x plus 6.
Yeah, x plus 6. Okay, so that's the completely factored form. So it said, rewrite the function in completely factored form and identify the restricted values. Does anybody remember what the definition was or how we find the restricted values? That's what we talked about yesterday. We wrote a definition. We did it a few times in examples. Marie?
Isn't anything equals to 0
in the denominator, yes, because that'll make it undefined. So what are our restricted values? Marie?
1 would be 0.
Okay.
And the other one would be negative 6.
Okay. So those would be the restricted values. Let's go on to the next box for this. It says identify the domain from the graph. So go ahead and look at your graph of f of x. Again, that's from page 238. Carefully look at it. Remember about all the properties we talked about with that graph yesterday. We want to write the domain of that graph. Who can help me out with those intervals? Marie?
It would be negative infinity to negative 6 with a parenthesis.
Okay.
It would be a union negative 6 to 0. And then again 0 to infinity.
Very good. We have to stop at negative 6 and then start again, and at 0 and start again, because those are the restricted values. So in the graph, we have a hole, and then we have an asymptote. So we have to stop at both of those, and that's the same as our restricted values we found in the first block. So the domain is going from negative infinity to infinity, except where your restricted values are. So it's always going from negative infinity to infinity, except where the restricted values are. All right. Set each non-canceling factor or factors of the numerator equal to 0 and solve for x. What do you think they mean by that? Set each non-canceling factor or factors of the numerator equal to 0 and solve for x. Rebecca?
Well, if the value appears in both the numerator and the denominator, you should not list it like x plus 6. You should not list it x minus 6.
Yeah, so non-canceling. So the x minus 6 is non-canceling because nothing on the bottom cancels it. The x plus 6 and the x plus 6 would cancel. So they're only asking about this one that's non-canceling, x minus 6. And they said set it equal to 0 and solve for x. Okay, that's all they asked us to do in that block. The next block kind of asks about it. What is or are the zeros of the function according to the graph? So look at the graph, f of x. Remember, a zero is where it crosses the what? Zero crosses what? Marie? Yeah, so your graph of f of x, where does it cross the x-axis? Looking at the graph. Marie? Okay, 6. So graphically we see 6. Mathematically?
Good morning, and please excuse the interruption. All students taking the ASVAB test this morning should report to room 86 at this time. Again, that's all students taking the ASVAB test should report to room 86. Thank you.
Mathematically and graphically we saw that x equals 6 is where it's 0. So we found the 0 here, and graphically we looked and we got the same answer. Alright, the next one is a little different. We may not have done one like this. I don't know that we did one yesterday. What is the value of the constant term of the numerator over the constant term of the denominator? Constant term of the numerator over the constant term of the denominator. What numbers do you think we're referring to? Constant term of the numerator over the constant term of the denominator. So we're going to have a fraction. What is that fraction? Does anybody know what the constant term is of the numerator? Rebecca? Yeah, the negative 36, that's the constant on the top. What's the constant term on the bottom? Do we have one on the bottom? No, if we don't have one, it's just 0. So this is undefined. So the next block is going to ask us about that. What are the coordinates of the y-intercept of the graph of the function? Well, do we have a y-intercept? No, because this was undefined, so no y-intercept. If we actually get a value for this block, whatever this value is, that is our y-intercept. Because in other words, what you're doing when they ask for the constants, if you really think about how we got negative 36, you plugged in 0 for x, and if you plug in 0 for x, you get negative 36 over 0. That's your x value, but the x value is undefined, so we don't actually have a y-intercept. Graphically, if you look at f of x, if you look at it graphically, we don't have a y-intercept. It never crosses the y-axis. All right. Do we think we could try h of x on our own then? So the next 3 examples are going to be dealing the same way. We'll go through, if you want to work on your own, through h of x, and I'll slowly put some answers up and you can check yourself on the way. If we have questions, be sure to raise your hand and ask any. Anywhere you get confused, I can go over it. But go ahead and work through h of x. As you're working, make sure to check your answers up on the board. If you have any questions, please raise your hand. We'll go over it. Alright, it seems like most people finished up with the second one. If you haven't already, go ahead to the third one, g of x. Start working through the next one if you have not. Again, at any point if you have questions, though, ask. Make sure you check your answers for g of x if you're finished with that. Any questions so far in any of the examples? Alright, if you have finished the third one, go ahead on to the fourth one and work on that one. And then you can check your answers with that one also. Bless you. Once you're finished with those 4 examples, if you have no questions, if you could just turn to the back so I know you're done with the front and we're ready to move to the next section. If you're still working, that's okay. I'll give you another minute or so. before we flip over, any lingering questions on the front at all? Pretty self-explanatory so far. Tori, you need another moment? Okay. Yep. Okay, is there anybody that still needs another minute on the front, or are we okay? Alright, let's go ahead to the back then. On the back, we have some, well, really they're kind of like definitions, sort of, that we want to fill in. It says, study the information you found in the table on page 338 to respond to the following questions. So from the equation of the rational function, how do you determine the restricted values? So just explain, how did we find the restricted values? What did we do, Marie? So we set the factors of the denominator equal to 0 and solve for x. That's how you find your restricted values. Set the factors of the denominator equal to 0 and solve for x. And again, that's for restricted values. From the equation of the rational function, how do you determine the domain? The domain. So we found the domain multiple times on the front of this page. But from the rational function, how do you determine what the actual domain is? And I mentioned it a couple times also while you were working. Describe how you find the domain. Rebecca?
We'll use the factors of the denominator, those are restricted values, and set that up in an interval.
Okay, and the interval always goes from where to where, though?
Negative infinity.
Yeah, with these, it's going to go from negative infinity to infinity, except where the restricted values are. So all values from negative infinity to positive infinity, except for the restricted values. All values from negative infinity to infinity except for the restricted values. And again, that's exactly what we did on the front side of the page. From the equation of the rational function, how do you determine the zero or zeros of the graph? So not looking at the graph, but just looking at the rational function, how do you determine what the zeros of your graph would be? How do you determine what the zeros would be? We did this on the front side too. You need to look back. Anna?
You said the numerator factors equal to 0.
Okay, that's half of it. That's half of it. There's one more important thing about it.
You can't use a value that's in the denominator.
Exactly. So it has to be those non-canceling terms. So set non-canceling terms or non-canceling factors of the numerator equal to 0 and solve for x. So you only set the non-canceling factors of the numerator equal to 0 and solve for x. That's how you find the zeros. Again, we had a couple examples on the front where some of the factors canceled. All right, last one here. From the equation of the rational function, how do you determine the y-intercept of the graph? So it may have been new today, but I think we caught on quickly. How do you find the y-intercept? Rebecca?
You put the two constant terms in the numerator and the denominator of each other.
Yep, divide the constant term in the numerator by the constant term in the denominator. Divide the constant numerator by the constant in the denominator. Again, that's for your y-intercept. So those are all the steps we took on the front of the page for different values that we had found. So we have two examples left at the bottom. It says, given each rational function below, identify the indicated information. So I know you did the problems on the front, so I feel that you can do these ones also. So go ahead and start these two on the bottom, answer everything that they ask for, and eventually I'll put some answers up here to make sure that you can check yours, that way you're going in the right direction. So go ahead and start the bottom two examples, please. For f of x, if you want to check your answers up on the board. The boxes were a little smaller, so if there's something you can't read, let me know. If you've finished f of x, go ahead on with g of x. Same process, factor completely, then find your restricted values in domain, zeros, and y-intercept. And if you finish g of x, you can go ahead and check your answers with g of x up here. As you're finishing up, do we feel pretty comfortable with the steps we've done then? I think that you guys are doing pretty well with it. We've had numerous examples. So we have the homework assignment after this section. You guys can start working on that. It's a lot of the same steps. I think you guys feel comfortable enough to finish that. If you have questions, you have some time to work on that and ask me questions. And tomorrow we'll start the next section and build upon this and really get into more to the graphs of the rational functions.